Hello everyone. So today we are going to solve a problem number 1287. Element appearing more than 25% in sorted array, and it is said in the problem that given an integer array sorted in non-decreasing order, there is exactly one integer in the array that occurs more than 25% of the time, and we want to return that integer. Okay, so one thing that I have noticed is this is a sorted array, so that's good. And there is one integer that is present 25 more percent of the time, and we want to return that integer. So what we can do is we can create one frequency map of the array that we have given, and what we can also do is this is my frequency map, and the another we can also create a set of array which will have we have only the unique distinct numbers in this set 1 2 6 and 7 and 10, and as we will traverse this array, we will check if this count frequency is more than 25% time of the length, and if it is, then we must say that this number that we have seen in the array set is present 25% of the time, and we want to return that number, right? So let's write this code. So that would be something like this. We want to create a hash map of the array. So that is this, and we want to create one array set which is set of the array numbers, and now for the numbers in the array we want to check this thing, like we want one length also. So n is my length of array, and we want to check that every number in my array set, if the count of this number is more than 25%, so which is 0.25 times n, and if it is that, then we want to return the number. Otherwise, if it is not, then we'll return 0 or -1, doesn't matter, right? So now let's run our code for example test cases. Okay, let's run our code for another example test cases. Okay, now let's submit our code and see how it is performed. So yeah, it has been accepted and it's running fast. So this approach has a time complexity of O of m, where m is the number of distinct characters in input array. That is one approach that I can come up with, and space complexity is same, O of m. But another approach that I was thinking about, like since it is given that my array is sorted, so we have, this is our approach 2. So sorted array. So we can apply binary search to find out these numbers, uh, to find out this integer which has occurred more than the 25% of the time. So we have the one integer in the array which has exactly occurs more than 25. So we have one length that we can define. Let's say just quarter, which is 0.25 of the original length n. So n is my original length of array, or this is, I would say, n is array dot length. Okay, this is the length of the array, and this quarter is the size of my uh, array string, of my array internally of the number that has been repeated more than 25% of the time. So it becomes like n divided by 4. So this models to n divided by. So what we can see is the indexes that where this integer could be present is 1 time n by 4, another is 2 times n by 4, and the 3 times n by 4. So these are the in indices of my integer which has been repeated more than 25% of the time. So what I can do is I can look for these indices position in my binary search, and if I have found that binary search from left and right, I could just check like if my right index minus left index is more than the quarter that I have present. So that means the correct index where this for the first time this integer would be shown would be this location of my index that I have found in the indices list that I have just created over here. So that array of index will return this. So this will give us the correct position of the element which has been repeated more than twice. So this is how we can write it out, code it out. So this is my second approach. So this is the binary search approach that I have come up with. So approach binary search. So what I'm going to do is first we need to calculate the length of my array, and there is this quarter that I explained you, that is n by 4, and the list of indices. So I'm saying that these are the candidates that is present at n by 4, 2 times n by 4, and 3 times n by 4. And now I'm going to check these indices in the original array and do the binary search from left and right. So this I will get the leftmost position of the index where I have first found this uh, integer in the array. So this I will get from the leftmost binary search, and if I do the binary search from the right hand side, then I will get the right hand side binary search, which is right from right. So this position would be index number 6. So this is, and I'm going to check that if my r minus l is more than quarter, then this is the first time where this index has been found, and based on this index I want to return the array value where I have seen this index for the first time. So I'm gonna return this one, and if we don't find anything, then we'll return just a -1. So now let's run this approach and see how it performs. Okay, so this has been running. So the time complexity for this approach is O of log of n, because we are dividing the array in half, and the space complexity is 3 times the candidate list that we have just created. It's a O of 3, so which is constant. So we can write it O of 1, and let's submit our solution and see how it performed. So yeah, so this has been accepted. So yeah, that's how you solve this problem, and it was a pretty good problem to learn about binary search, like how we can do the application of binary search and the traversal algorithms both. So yeah, thank you.